Right, we have with us today Dr. May Wang from Georgia Tech University, Georgia Institute of Technology and Emory University. Welcome, Dr. Wang. We really appreciate your time. You come here and give an opportunity to us to interview you.
I'm happy to hear.
Okay, tell us something about yourself and what you're working on, your research.
Okay, I'm an associate professor in the joint department of biomedical engineering, department of Georgia Tech and Emory University. This is one of the very few departments in the whole country that actually consists of both engineering school as well as school of medicine. I got my PhD from Georgia Tech. I worked in industry for a few years, and I was recruited back by Georgia Tech to this department. My own research has been really on the integrated biomedical and health informatics, and right now people give it a new name called biomedical big data analytics.
Oh, and I loved your speech. It was phenomenal. So what do you think are the key issues in the biomedical big data analytics?
So currently, people keep talking about big data, and then because they're thinking about big, the main thing they usually are thinking is volume, big. But in fact, big data consists of multiple elements. Not only we talk about the big, but really it's also, we sometimes use 4 V words. So such as besides volume, we're also referring to variety, because in this data area, we sometimes have multi-modality, multi-skill, different kind of data. And that's actually present a variety in medicine. And then the third V word is velocity. As we all know that when we're trying to measure information about us, human, we have multiple time scale when we measure data. So that's why when the data represent different velocity. The last one is the veracity. I definitely know some people are talking about value, but right now I'm presenting it within the term of technical term, which actually really we're referring to the data integrity. In addition to that, there are also some other issues in the big data. When we talk about this kind of 4 V's, fundamentally, we're really discussing a very complex, unstructured data. For example, doctor's notes, handwritten notes, right? That's very unstructured. For example, when we're talking about even measuring the clinical information, we sometimes don't have exactly the time scale for every single patient coming into the hospital, right? So we have a big, complex, unstructured data. However, that's not the only issue. There's a lot of other issues, such as, for example, privacy and security. That's a big issue. For example, data itself, when we get into the information, when we need to go for information to what we call the knowledge and modeling, that's a big step because medicine is such specialized. So if you're not linking to knowledge, just using information, those features themselves, they do not make any sense. So that's a big issue when we're trying to work on that, because medicine, as we all know, the physician needs to take multiple steps to get trained. For us, working in big data analytics, how do we actually model that, right? Using analytics algorithm as well as a software system to do that. That's actually like a physician being trained. And then in addition to that, the knowledge is not equal to decision. So when we're trying to make a decision, and there's also an important step towards how we navigate through the knowledge to decide what to do. But more importantly, in this whole process is this feedback loop, because not every single decision is actionable. So that's why if I would like to summarize some of the big data analytics issues, I would actually say that besides the 4 complex and unstructured data, then another major issue is this entire process from data, dealing with the quality, the sampling of data, to information, how do we deal with curves of dimensionality, to the knowledge modeling, to the decision making, how do we do case-based individualized decision making, based on the population statistics. And then two, the last step, the feedback loop for actionable items. Are the major issues for big data analytics. And then among the process of doing this entire process, sometimes we also really are facing the challenge of we have thousands of methodologies and pipelines, which are the ones the most suitable for the data you're dealing with. So that's why, in my view, the big data analytics is only in its infant stage. There's much more time for us to fully explore the field.
Well, yeah, that's true. I heard your speech. It's totally in an infant stage after looking at the view that you gave in your speech.
Yeah.
So where do you think is the biomedical research going to be in the next 5 years?
So biomedical research right now is a very open and fast-growing field. Currently, that's actually coming back to the biodata analytics within the biomedical field. We actually say that if you look at the National Academy of Engineering, when they actually put a mission statement for the 21st century, they identify the 14 grand challenges for the 21st century. And actually one of those is this health informatics. So when we're talking about this kind of informatics, as I said, the big data analytics is the rewarding of the informatics, right? The challenge right now, what's going to happen at this particular moment is we have multiple technologies became available, from sensors to biotechnology like omic technology. So that's the reason why at this moment, if you're talking about immediately the next 5 years, our main research opportunities lie in two places. One, among I said, multiple different kind of informatics. So what are these? We usually summarize into 5 categories. One is bioinformatics, dealing with the human genome, proteome, metabolome, microbiome. Second one, image informatics, because we start moving from radiology, organ imaging now to early detection. That's why we move to molecular imaging. So we have a lot of imaging data. Three, the clinical informatics. Right now we're doing a lot of electronic medical record, trying to make everything in the structured electronic diagnosis note, so we can utilize that for large mining as well as for intervention. For public health informatics, for example, how to deal with, because of globalization, people travel around, how do we actually deal with infectious diseases such as Ebola, right? Such as SARS, HIV. So then the last one, now we're actually taking care of our health from hospital back to home, patient-centric health model. Such we're going to utilize a lot of sensors at home, so sensor informatics. So all these 5 together under the big umbrella of biomedical health informatics is what's happening at this moment right now within the incoming 5 years.
That's pretty interesting stuff, I must say. So what encouraged you to come to this conference?
I'm actually being asked by my friend called Holly to actually serve as a technical program committee member. I reviewed the 9 manuscripts in this process, and then later I'm being asked to share my experience in the big data analytics.
Indeed, it has been a pleasure to have you here. Thank you so much for coming and getting interviewed with us. We really appreciate your time.
Thank you.